Question 1. This was asking you to draw a frequency polygon. Now, as soon as you see that word frequency polygon, you should be thinking of two things immediately. First of all, it's a line graph, and it's plotted at the midpoints. So I'd recommend creating a midpoint column, just an MP column by here. So we're looking for the middle of 10 and 20, which would be 15 and 25, and so on. Once you have found all of these midpoints, you are then going to plot these on your graph. So I'm looking for 15. So 15 to, so we're bang in the middle here. And then I want to go up to a frequency of 5. So I may plot these a little bit out because I'm doing it on the iPad, but they need to be accurate on your diagram, okay? So 15 and 5, then 25 and 9. 25 and 9. And so on and so on and so on. So it looks something like this. Like I said, mine might be a little bit out because I'm doing it on the iPad, but you do need to be accurate when you're doing these things. And then you would join these up with a ruler, so these should be straight lines, which again, mine might be a little bit wavy, yours should be with a ruler. Okay, and it should look like that, and that would get you the 2 marks. Okay, and so question 2 gives us a frequency polygon, shows the age distribution of female members. Now, a couple of misconceptions here. Some people said that there's something like 3 people who are like 15 and so on. That's not true. That's plotted at the midpoints. That's anywhere between 10 and 20. So be wary of that. A few of you had that. As you can see, I've got my frequency polygon for the last question side by side. Now, when you're looking at making comparisons of the data, the things that you want to be talking about are like modal class and maybe the range. They would be the best 2 ones to go for. Okay, so in terms of the female members, let's have a look at their range. Their range, 15-ish. Remember, this could be anywhere between 10 and 20 to 55. So look at that, that's quite small in comparison to the males, where the males was that one there to there, okay? You can't actually go and work it out, because like I said, this value here, we just knew that was somewhere between 60 and 70, we plotted it at the midpoint, but you can say that the range for males is bigger, meaning that there's a bigger age distribution between them, okay? So that's all you need for one of those marks. Okay, so I won't make you watch me write it down, but it's something like that. The range of male members is bigger than for females. For the other one, if we look at the females one there, their peak, their modal class is that 55 one, whereas the modal class for men is what here between 40 and 50, whereas the ladies were between 50 and 60. So looking at that, we'd say that the modal class is at a younger age for men. So there we go, something like that. So feel free to pause the videos and get this written down if you had these wrong. Okay, so for the first 2 marks here, really important you're getting these. You're plotting these on the right axis, so 1 or 2 of you misplotting these. Time on the telephone, so that's the y-axis, so 275, so I'm looking at here, 275 and 125, so roughly there, okay, I'll plot these in a second, but make sure you're plotting on the right axis. So look at those points there, that's how they're plotted. Again, roughly for me, because I'm on the iPad, but you need to plot those correctly. And as you can see, as I've plotted one, I've just ticked it just so in my own mind I know I've got those done. Now, I saw some very strange lines of best fit. Look at where your dots are, they're all by here. So if you had to predict where those dots were going, where would they go from the graph paper? Well, I'd assume to see more dots down here and more dots up here. Some of you draw lines of best fit like that, and that's not true. That's not where I'd predict those points to be. Okay, now your line of best fit should have roughly the same amount of points each side of the line, and it should predict where those points are going. So all scattered around here, and then you draw your line so it's got roughly the same amount of points each side. Okay, so there's a generic line for me, what I think it would look something like. That's not a bad line at all. You don't have to try and get lots of dots on the line, that's a misconception. I think maybe you have to in science, but that's not the case in maths. And again, like I said, it should just have roughly the same amount of points each side of the line. So what have we got? 1, 2, 3, 1, 2, 3, 4, 5. So you could maybe argue that I could change my line. Now I've got the benefit of being able to do that. So there we go. Now I've got the same amount of points each side of the line. So we've got 1, 2, 3, 4, 1, 2, 3, 4, 5, and then you've got that one there as well, 5 each side of the line. Now, for the next bit here, it says, on the same day she spent 200 minutes on the telephone. Now, it was actually, didn't matter what your line looked like. As long as you had obviously gone and read off your line, then you would have got the marks here, okay? But make it really obvious for me. So draw a line going up from the 200 and coming off over here. So for me, I don't know, approximately 150. You could argue that I'm 1 square down there, but I haven't got a ruler, so I can't actually use it here. As long as you've done that off your graph, you will have got the marks. So I'll go and write down here, for me, for my line of best fit, I've got 145, but as long as it is whatever your value is off that line, you will get the marks there. This was one of the worst answered questions by the whole class. Okay, now cumulative frequency, the word that we were associated with that was the word running total. You needed to create a cumulative frequency tally. So cumulative frequency adds the frequencies as we go. So the first one is just 8. The next one is 18. The next one would be 18 add 14, so what's that? 32. And then the last one would be 40. And checking the question, it should tell you how many journeys there were, 40. So that had to be 40. The next thing you need to remember is that you plot the cumulative frequency against the end points here. Okay? So a couple of you not doing that. So I need to see 8 and 8 plotted. So I'll plot all those points. I won't make you watch me do that. But you need to plot the end points. I saw one person actually highlight the end category. I thought that was a clever way of doing it. So plotting those points made it look like that. You then need to join these up together. Okay, so there, and then again, that should have been done with a ruler. You were then asked down here to estimate the median journey. So there's 40 altogether. So to work out the median, you go from the middle, which would be 20. So I need to see a line coming across from 20 till you hit your graph here, and then coming down and reading off what that value is. So I make that from my graph 26. Now you'll see, you might have seen that I put ECF and gave you the marks there. That means error carried forward, and that's because you were doing the right thing. I'd like to see written on your graph as well, m equals 26, like that. You were then asked to estimate the interquartile range. So you needed to draw values going off your graph at half of the median, which would have been 10. So let me use a better colour than that. So drawing across from 10, hit the graph, come down. So that looks like 21 to me. So say LQ, that's the lower quartile, is 21. And the UQ would be the 20, add the 10 there, which would be coming across at 30. Hit the graph and come down there. So again, from my graph, that looks roughly 29, but like I might be a little bit out because I've done it all freehand. Yours will be more accurate, so you'll have used a ruler. So the interquartile range would be 29 minus 21. In my case, like I said, your graph might be slightly different to mine. Yours will be more accurate, so yours will probably be better than mine. And I need to answer it is 8. Okay, now cumulative frequencies can also be drawn as box plots. And it says here that Jay makes the same, my times are quicker and more consistent than Dan's. Now, to see if things are quicker, we would look at the average. So we'd look at the median time. To see if things are more consistent, we would look at the interquartile range. If you remember, I looked at doing some data with you on previous classes I taught, and I looked at saying if they've done better, their median will be higher because they will have done better in the test, and their interquartile range will be smaller, meaning they're more consistent. So for that to be consistent, we need a really small interquartile range. If it's really big, it's telling me that they're very inconsistent. And median, because we're talking about quicker, we want it to be smaller and smaller and smaller. So let's look at Jane's one here. So this is Jane's 40 journeys. So Jane has a median time of, what's that? So there's 20, 1, 2, 3 of 23 minutes. And the one from the previous question was 26 minutes. So compared to 26 minutes by whoever it was before. By, who was it? By Dan. Okay, so compared to 20. So she is quicker. Okay, but reference that, make it really obvious. So she is quicker. Her interquartile range, well, this is the lowest point, this is your min point, this is your, not your min, your min point, this is your lower quartile, this is your median, this is your upper quartile, and this is your max. So we need to go and work out her interquartile range, so that's 32 and 19. So I'll maybe do that in a different colour actually. So Jane's IQR is equal to 32, take away 19, which is, what's that, 13? Now Dan's was much smaller than that, his was 8, okay? So compared to Dan's IQR of 8, this is less consistent. The bigger that interquartile range, the less consistent you are. So she's wrong there. She's right saying that she's quicker, but she's wrong saying she's more consistent. Okay, so compared to Dan's interquartile range of 8, this is less consistent. So she is wrong on this part. Okay. Okay, the next question was saying, or was asking you to work out an estimate for the mean. Now they're very lucky with for you here. Look, they even did the 2 columns. You usually got to put those in yourself. Okay, so your midpoint column, and we should be greying out as soon as we draw the midpoint column. So the midpoint there, 5, 15, 25, 35, and 45, and this would be the midpoint multiplied by the frequency. So 5 times 5. Some people like to go and put a time sign in between. You don't have to, but maybe it's like quite nice. It sort of illustrates exactly what it's going to do. So 5 times 5 is 25, and so on. So working out all those numbers, they are as follows. Now you should be working out the total frequency and the total of the midpoint times frequency. Now this is given in the question, okay, but it's worth just adding them up just to check it is 80, because that number isn't necessarily definitely going to be the number that makes that there. So just add those together if in doubt. So add these numbers together if in doubt to get the 80, and then add these numbers together as well to work out that total. So that comes to 1,970. Now to work out an estimate for the mean, it's always this column here, the total of the MP times F. So total MP times F over the total frequency. Okay, so in our case then it's going to be 1970 divided by 80. Never write 2 equals on one line, so then equals underneath here, and that equals 24.625. Now, as that's only 3 decimal places, you just write that in here, okay? If it's a longer number, then yes, round it. But you'll see on a number of your pieces of work that I would have like crossed out 25 and just pointed to this answer here. It's only 3 decimal places. Just write it in there. It's easier. Now, there are a number of different ways to do this here. So it says, the doctor says 70% of our patients waited less than 30 minutes to be seen. There are 80 patients altogether, so we need to go and work out 70% of 80. Now 10% would be equal to 8, so 70% would be 7 times that, so it's 56 patients. So less than 30 minutes, that's what it says there. Now my favourite way of showing that was saying, right, we've got here times from 0 to 10, 10 to 20, and 10 is less than 30. So we're interested in these people here. So what we wanted to do was to add together these frequencies. So 5 add 22 add 28, 5 add 22 add 28, and that comes to 55. So he said 70% of our patients wait less than 30 minutes to be seen. Is he correct? No, he's not correct, because he's slightly off. It is very, very close, but he's not correct. He is 1 person out. So the answer is no, he's 1 out. What you could do to prove it is you could say, well, that 55 there, out of 80 times by 100 is 68.75%. So he's just rounded it up to make it sound a bit more impressive, is what I'd say there. Is not true. It's actually slightly less than that. Okay, so this question said the word histogram. As soon as you see that word histogram, I want you to be writing this triangle, FD, CW, and F. Okay, now you need to go and create columns by the size. One called class width and one called frequency density. Okay, so the class width we work out from doing that big number to take away the small number. So 2.5 take away 1, so 1.5. This one would have been 3.5 take away 2.5, so just 1. This one would also be 1, and this one would be 1.5. So now, to work out the frequency density here, we cover that up and we'd be left with F over CW. So that means I'd need to do 45 divided by 1.5, which comes out at 30. The next one's really easy. 490 divided by 1 is 490. And the next one is 270 divided by 1, which is also 270. And 195 divided by 1.5 comes to 130. Now the main mistake that was here was that this bar graph was drawn wrong. Okay. Now it says here that's between 1 and 2.5. Your frequency density will have to be going up the side. Now, not the nicest scale in the world. You're obviously going to need to go to a maximum of 490 sides. I would have said go up in hundreds for like 10 little squares here. 1 second, what have I done here? So I would have gone up, let me zoom in here. So 10 little squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That thing there, that would be 100, and so on. So I'll draw the rest of those, but hopefully your graph paper is maybe a little bit easier to see than this. There we go, I've drawn in the rest of those. I'd title that as well. No one did, but I wasn't taking any marks off this, but should technically say frequency density. So then, look at that bit there. You had to draw your first bar between 1 and 2.5, and loads of you just drew from 0 to 2.5, so be careful on that. It's a really silly mark to lose. So coming here to 1, and then up to 30, so 10, 20, 30, and going all the way across then to 2.5 here. That should have been your first bar. Now the next bar was huge, wasn't it? Didn't it go up to 490? Yeah. So that's between 2.5 and 3.5. So you needed to draw that going all the way up to 490. Now again, use a ruler. I haven't got one. So there, and that went across to 3.5. So what's that? 3.5. There. Okay, so again, like I said, you'd use a ruler. Then 270, so that's 3 down from 300, and that went across to 4.5. And then finally 130, and that went up to 6. So there's 100, 3 up from there. So like that. Okay, so that's what your histogram should look like. Let's just maybe make this look a little bit more standoutish, or see bad. Like that. Okay, but like I said, you must use ruler. You can't do that in the exam. I just can't from the program I'm using. Okay. Now this question was pretty well answered, to be honest. It says in the question here, it says Kirsty says 30% of the students take more than 25 minutes to travel to school. We know there's 270 students in the school, so 10% must be what, 27. So 20% must be double of that, which would be 54, and then 30% you would add those together. Now this was a calculated paper, but it may come up non-calculated paper, so that's one way of working it out. Now to work this out here, we want to use our FD, CW and F triangle again. Now to work out more than 25 people, you're looking there at drawing a line there and say, look, we want these people here. So let's work on this bar first. Okay, that's quite easy. The class width of that is 20 because it runs from 30 to 50. 50 take away 30 is 20. So I know the class width is 20, and the frequency, if we can read it off, is 2. So to work out the frequency density is 2. So to work out the frequency, cover up F, FD times by CW. So 20 times by 2 is 40 people in there. Okay. Now the next one here is a distance of 5 between these two, and then that is a frequency density of 6. So to work that out, you would do 5 times 6, which is 30. So there's 30 people in that bar. So 30 plus 40 equals 70 people take longer than 25 minutes. Well, the claim then in that case is wrong, because we know that 30% of people is 81, and it's actually only 70. So that's too many. Again, another way to prove this if you wanted, as long as you explain that, you say this is wrong. This is a wrong statement, as 30% is equal to 81 people. Delete that bit. 30% is equal to 81 people. People there. Whereas the histogram would suggest that only 70 people took longer. Okay, what I would like you to do now is to turn back to the front page, and I'd like you to pick out what you think is the hardest mark in that test and write down what went well from probably the hardest thing that you did. So histograms would be A star work, cumulative frequency is B grade work, whereas scatter graphs and estimating the mean, that's only C grade work. So can you tell me something that you think you did well, and tell me why you think you did that well? And can you tell me something that you've missed marks on and would be even better if in your test, please?